All right, Algebra 2, here we go. We're going to be starting this next unit, which we've done a decent amount of it already as far as just in our previous work. A lot of the concepts have been around, so we are still going to go through this, but some of this should be review. All right. Going to be doing a few Zooms this week. For you guys, if you have any questions, if you want to ask questions, I know some people have been emailing me about their grades. I'm getting grades going. I just finished grading a bunch of the seniors' final projects because they're out of here after this week. So I've been just catching up on those things. So I'll be getting the rest of the grades in throughout this week. All right. If you've been emailing me, I have heard your emails and I will get to them shortly. All right, so let's get started with this. Without further ado, this is Unit 6. All right, Unit 6. Yeah, I'll put this up at the top, actually. 6-1. All right, and this is Roots and Radicals. All right, and I had you guys do a little review assignment. All right, this is going to be a review lesson. We need to be able to use Roots and Radicals for this lesson, for this unit. All right. So first thing we're looking at is our perfect squares. What are our perfect squares? Write those down. You guys should have those down at this point. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, perfect cubes. 1, 8, 27. Trying to leave some space here. 64, 125. 216, 343. 512, 729. Okay, and then perfect fourths. So, you guys know what perfect cubes are. You know what perfect squares are. 1 times 1 is. If I pull the highlighter out, hold on 1 second. There's no highlighter. Okay, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9, as we see here. 4 times 4 is 16. That's how we get our perfect squares. 1 times 1 times 1, right, at perfect cubes is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 right there is 27. Okay, so we can see why we call those perfect squares and perfect cubes. Squares are numbers that we have when it's multiplied together twice. Perfect cubes multiplied together 3 times. Perfect fourths multiplied together 4 times. 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 or 2 times 2 times 2 times 2 is 16. All right, so we're going to write these out. 3 times 3 times 3 times 3 is 81, so on and so forth. So 4 to the 4th power is 256. It's a perfect fourth. 5 to the 4th power is 625. 6 to the 4th power, 1,296, increasing much faster. 7 to the 4th power is 2,401. All right, so on and so forth. Okay, so we've written down our perfect squares, our perfect cubes, and our perfect fourths. All right, or at least the first few of them. All right, and that's fine. All right, so parts of a radical. The nth root of a real number, a, can be written as the radical expression. All right, so this is an n root. All right. So what does that n stand for? That's what's known as the index. Okay, so write that here, index. You guys remember this should all be review. So I'm just going to kind of go through this quickly. Radical sign here. And the a inside is the radicand, or the radicand. I say radicand. All right, if there is no index, assume that n equals 2. So, here we don't see any index, right? It's because it's a square root, right? All right, give all the possible roots to the radicals below. All right, so just go through these quickly. Square root of 16. All right, remember it's plus or minus 4. We're doing that all the time now, okay? So square root of 121, 11 times 11, or negative 11 times negative 11. So it's plus or minus 11, because it could be a positive 11 or it could be a negative 11. So it's positive or negative 11. All right, 289 is a perfect square. All right, so for 289, we have positive or negative 17. All right, and then for this, remember that this is the same as the square root of 4 over the square root of 25, all right, which would give us, what's the square root of 4? 2. What's the square root of 25? 5. So, it should be plus or minus 2/5, though. All right, plus or minus. All right, cube root of 8 is 2, not plus or minus here, all right, because it's an odd power, right? You'll notice once we get back into the fourths here shortly, there will be positive and negatives, all right? Cube root of 343 is 7. Cube root of negative 125. Can we do a negative cube root? Yes, we can, right? There is no I involved in this, right? Negative 5 times negative 5 times negative 5 will give us 125. All right, and what is the cube root of 1? The cube root of 1 is 1. The cube root of 27 is 3, and because it's a negative, this will also be negative. So it's negative 1/3. All right. For the fourth root of 1, positive or negative 1. 1 times 1 times 1 times 1, or negative 1 times negative 1 times negative 1 times negative 1. For the next one, 2,401, right? We have that up here, right? Let's look up at the top at our perfect fourths up here. You see 2,401. So this is 1 squared, 1 to the fourth, 2 to the fourth, 3 to the fourth, 4 to the fourth, 5 to the fourth, 6 to the fourth. So this is 7 to the fourth power. So this is going to be plus or minus 7, because it's a fourth root. 7 times 7 times 7 times 7, right? The next one is going to be plus or minus 8, positive or negative 8. And then finally, 81 over 16, right? Both of these are perfect fourth roots, right, as we can see above. So it's going to be plus or minus, right? The fourth root of 81 is 3 over 2. All right? Fantastic. All right, so if the index is even, right, and the radical is positive, right, then what we are going to be doing, right, if the index is even and the radicand is positive, right, first of all, it says type of roots, right, these are going to be real. It's going to be a real number, right? So even positive, right? So look up here. We have an even root, right? It's a square root with a positive radicand, right? Positive 16 is inside there, right? Everybody sees which one I'm talking about. So that falls into this category. So our answer is a real number, 4, right? And how many are there? Well, remember, it's plus or minus 4 there. So the number of roots we have are 2. One is going to be positive, and one is going to be negative, all right? If it's odd and positive, all right, again, we will have a real root. The type of root will be real. There will only be one answer, though, all right? And that answer will be positive, all right? Guaranteed that answer will be positive. Now, if it's an odd negative, we will have a real answer again, right, a real root. There will only be one root, and it will be a negative number. And then finally, this one has a star next to it. It's an even negative, all right? This is going to be imaginary, so I'm just going to put IMAG for imaginary, all right? There will be 2 roots, right? And it'll be one will be positive and one will be negative. Remember that the I will be in there, okay? All right. So let's go through this. If a radical has more than one root, this is again review. All right, so I'm going to go through this quickly. I will have some Zoom meetings this week, so if you feel a little bit behind on this, you feel it's been a while that we've done this, whatever it might be. All right, you're going to have to join one of those Zoom meetings, and so we can talk and get through this. Okay, but again, we have done this, so I'm going to go through this quickly. All right, so I'm looking for 2 numbers that multiply together to get 117. And I want one of those numbers to be a perfect square. All right. Now I'm going to put both of those numbers inside of the square root signs. All right. Both of them will be inside of a radical sign. Okay. So for square root of 117, all right, the two numbers, all right, that multiply. Well, I could start looking and say, okay, let's see, 1, we don't use 1 though, all right, but 4, no, 4 is not going to go into it. 9 times 13 would give us 117. So here's what I'm going to do. I'm going to write square root of 9 here, right, and the square root of 13. All right, what is the square root of 9? All right, the square root of 9 is 3. Whoops, here, let me do this. Is 3, and the square root of 13 cannot be simplified, so we're left with 3 square root of 13, and that is our final answer right there. Okay? For this one, we have a 4 already on the outside here. All right? That's just going to hang out there, and if we do find a perfect square, we're going to end up multiplying whatever that perfect square is to the outside number. Okay? I'll show you what I mean here. All right, so that 4 is going to hang out here. We're going to keep writing that here. Now, what two numbers multiply together to get 320 that has a perfect square? Well, the square root of 64, right? That's a perfect square, times 5 would give us that. So square root of 5. What is the square root of 64? It's 8. So this is now, all right? And here's where it happens, right? We're bringing everything down, but we're going to make sure that square root of 64 is simplified. So now this becomes 4 times 8 times square root of 5. Right? And gives us our final answer here. What's 4 times 8? 32. And square root of 5 cannot be simplified, so that is our final answer there. All right. Here we are on the cube roots. All right, the cube roots. So, right, what's there first? All right, 2 is on the outside. We're going to keep that there. All right, 2. Now, what are two numbers that multiply together to get 48? We're looking for perfect cubes now. So we're looking for these numbers that will be multiplying, okay? So I'm going to try 8 first. 8 times 6. Oh, sweet. We got it. All right. So this is the cube root. So it's the cube root of 8. That's what that little 3 is there, cube root, right? Times the cube root of 6. Well, what is the cube root of 8? It is 2. All right. So we need to write both of these down here. So we end up getting 2 times 2 times cube root of 6. All right, and what's that going to end up leading us to? That will end up being 4 cube root of 6. All right, that's our final answer, because cube root of 6 cannot be simplified. Right? And how do you know if it can't be simplified? Right, well, are there any perfect cubes inside of 6? No. Right, 1 times 6. Well, 1 is a perfect cube, but you can never use 1, right? And the other one is 2 times 6, right? Or is cube root of 2 perfect? No. Is cube root of 3 perfect? No. So it's simplified as it can get. All right, that's how you know. All right, for this one, 108, 3 on the outside. All right, so we're gonna keep writing that on the outside here. All right, 3 times. What are two numbers that multiply together to get 108 that has a perfect cube in it? Well, the cube root of 27, all right, 27 is a perfect cube, as you can see up here, right? Boom, right there, right, 27. So I'm going to try that. 27 times 4, perfect. So this ends up being 3 times the cube root of 27 times 4, the cube root of 4. All right, and what is the cube root of 27? That is 3. So we end up with this 3 here times cube root of 27 is 3, and we're left with times the cube root of 4. Can we simplify that? No, we can't, but we can multiply the outside to get this finished. All right, so here we go. We are left with 3 times 3 is 9, cube root of 4. All right, and that's our answer there. Cube root of a negative. All right, now look, again, what are we, the whole purpose of this chart here is to kind of, this is an even number, right? Number one, it's, oh, sorry, not an even number, it's an even index. All right, it's an even index. It's a square root. All right, there's a 2 here. We don't see it, but there's a 2 on that index, okay? So it's even, it's positive, right? So what is our answer, right? Well, these answers right here, right, they should be, and that's my fault, plus or minus, right? And how do we know that? Again, it's an even index, right? The radican's positive, right? So we know it's going to be plus or minus, right? That's how you know, right? This is this chart that's telling you that, right? So again, we have an even degree for number 2, right? A positive radicand, right, on the inside. So this is going to end up being a plus or minus here as well, right? There we go, plus or minus. Now down here, these are fine the way that they are, right? Because it is an odd index, right? A positive radicand, so there's only going to be one answer. You can see that right there, right? And that goes for both 3 and 4. All right, so here we go. We have an odd index, right? A negative radicand. The radicand is a negative, so we're going to have a negative answer here, all right? So what two numbers? Now I'm going to make the negative number my perfect cube, all right? So negative 125, all right? So I'm going to go ahead and do this. Cube root of negative 125, right, times the cube root of 2, right? What is the cube root of 125? Negative 125? It's going to be negative 5, because negative 5 times negative 5 times negative 5 gives us negative 125. So negative 5 here, and we just leave this as the cube root of 2. All right, and that is our final answer there. All right. Negative 2 here, right? Can negative 2 be simplified? Well, if you're looking for that perfect cube, again, it's going to be negative 1. But this is why we don't ever need to do that, right? If I said, okay, negative 1 times the cube root of negative 1, the cube root of negative 1 times the cube root of 2, all right? Well, let's simplify this. What's on the outside, by the way? 6, right? 6 is on the outside. Now, the whole purpose of this is just to get we can't have a negative on the inside, all right? So you got to get rid of that, all right? So this whole process here, if there's a negative on the inside, it's not simplified all the way, right? You might say, well, 2 can't be simplified. Well, no, you're right. It technically can't, but we can get that negative out from the inside of the radicand, all right? So here we go. 6, what's the cube root of negative 1? It's going to give us negative 1. Negative 1 times negative 1 times negative 1. So we have 6 times negative 1 times, and what's left over, the cube root of 2. All right, 6 times negative 1 gives us negative 6, cube root of 2. All right, 3 and the 4th root of 162. All right, so let's just go ahead and do this real quick. 3 times, what's a number that is a perfect cube, perfect fourth, that multiplies together to get 162? Well, 81 times 2, so 4th root of 81 times the 4th root of 2. What is the 4th root of 81? It's 3. 3 times 3 times 3 times 3. All right, 3 to the 4th power is 81. So for the 4th root of 81 would also be 3. Right, and we're left over with that. 3 times 3 is 9. 9. Again, if you're having trouble with this, following along, all right, you can also look at your old notes, all right? They're very similar to this. But you can also join me in the Zoom meeting, all right? Number 8. All right, we're almost there. We're getting through this. We're almost done. All right, we have variables after this, which is not nearly as you guys have done those in the past, and those aren't too terrible. So here we go. All right, 5 is on the outside. What two numbers multiply together? Well, again, you could cut. I think I've told you guys this many times in the past. All right, I'm going to try 1,296. Right. And the square root, or the 4th root of 2. Okay, so 5 is going to be on the outside here. Times the 4th root of 1,296 times 2, the 4th root of 2, that is. All right, and what is the 4th root of 1,296? Well, 6 times 6 times 6 times 6 gives us 1,296, so it is 5 times 6 times the fourth root of 2, and 5 times 6 is 30 fourth root of 2. Now, for those of you that are like, dude, this guy keeps forgetting his plus and minus signs, you're absolutely right. This should be plus or minus, and this should be plus or minus, because why? Very simple. They are even indexes, right, with positive numbers inside, and that's what our chart told us right back here. Okay, that's what that chart is telling us. All right, let's get this finished up. We're going to do, just for time purposes, and because we just did all that review, we're just going to go ahead and do the odds here to finish it up. All right, square roots, exponents must be multiples of 2. Exponents must be multiples of 3 for cube roots, and for fourth roots, yeah, you guessed it, 4. Not really sure what the purpose of that is right now. All right, well, I do, but you guys have done this already. Again, all right, so here we go. 32, x to the 4th, y to the 9th. All right, let's go ahead and simplify it. What is the square root of 32? Square root of 32 is 16, all right? I'm sorry. I was looking at the wrong problem, all right? Square root of 32 is not a perfect square, of course, okay? Not a perfect square. So, what do we need to do here? All right, we need to do the same thing that we've done in the past. We need to try to find a perfect square, all right, that multiplies together to get 32. All right, multiplies by some number to get 32. So, what is half of 32? Right, that's the highest number that we could possibly try. Well, half of 32 is 16. Guess what? 16 is a perfect square. Cha-ching. So, what does that mean? It means it's going to be square root of 16 times, and this is tough because I just don't have a lot of space, right? Times the square root of the square root of 2. All right. What is the square root of 16? It is 4. All right. So we have 4 on the outside. All right. 4 on the outside. All right. The 2 is going to be on the inside, but we need to leave space in the front there. All right, because 2 stuck inside because this can't be simplified, right? So that's why it's still inside. Square root of 16 is 4. That's why that's on the outside. Now we have to deal with the variables. X to the 4th. Well, x to the 4th, right? What number multiplies together twice, right, to get x to the 4th? X squared times x squared is x to the 4th. So x to the 4th is a perfect square. All right, if we're talking about square roots, any even exponent is a perfect square. So this is going to be x squared on the outside, right? Nothing left on the inside because this is even. And then we have y to the 9th, right? Y to the 9th, 1 less than that, right? We put that on the inside. Remember that, all right? If it's an odd, subtract it by 1, put that on the inside. Now it's y to the 8th, right? And half of that is y to the 4th. Y to the 4th times y to the 4th gives us our final answer there, okay? Number 11, we're just doing odds here, okay? 216 is a perfect cube, all right? It's a perfect cube. All right, what is the cube root of 216? 8. 8 times 8 times 8, so 8 is on the outside. Well, n to the 3rd, right? Is that a multiple of 3? Yes, all right? So what number multiplies together 3? What multiplies together 3 times to get m to the 3rd? M. All right, and then what multiplies together 3 times to get n to the 6th? Because 6 is a perfect multiple of 3 as well, correct? Yep. So it's n to the 2nd times n to the 2nd times n to the 2nd would give us n to the 6th. So we would put the n to the 2nd out here. No plus or minus, all right? And we are all done with that problem. Excellent. All right. Number 13. Let's look for our perfect cubes here, okay? Perfect cubes. Negative 64, is that a perfect cube? This is another method, by the way. This is the method that they're showing. That's why I'm kind of pausing here. I do like this. All right, I'm going to show you this method as well for the last few problems. I think that this is a good way of looking at it, okay? So we're going to separate our perfect cubes from our non-perfect cubes, okay? So negative 64, is that a perfect cube? The answer is yes, all right? It is a perfect cube, all right? Negative 64, if you look at your chart, 4 times 4 times 4 is 64. So negative 4 times negative 4 times negative 4 is going to give us that. So negative 64 is a perfect cube. All right, so what we're going to end up doing is we're going to put our perfect cubes in here and our non-perfect cubes in another one next to this, okay? So far we don't have anything, okay? x to the 10th, right? Is x to the 10th a perfect cube? Is 10 a multiple of 3? No, right? 3, 6, 9, 12. So 10 isn't there. All right, so what do we have to do to get it to be a multiple of 3? We can subtract that 10 by 1. So what we need to do is put one of the x's inside of here. All right, and now we're left with x to the 9th in here. All right, that's a 9. I know it's kind of tough to see. All right, and then finally y to the 21st. Y to the 21st. It is a multiple of 3. All right. So negative 64. These are all perfect cubes in here. All right. So negative 64. That is going to give us negative 4 on the outside. All right. The cube root of negative 64 is negative 4. The cube root of x to the 9th. Right. X to the 3rd times x to the 3rd times x to the 3rd would give us x to the 9th. So it is a perfect cube. And then y to the 7th. Just divided by 3. All right, 21 divided by 3 is 7. Done. All right, and then we're left with the cube root of x on the outside, and that's our final answer. All right. Next one here. All right. W to the 4th. All right, it's the 4th root of w to the 4th and v to the 17th. Okay, so is w to the 4th a perfect 4th? Yes, it is. It's a multiple of 4. All right, so again, I'm going to put all my perfect ones over here. Okay, so this is going to be w to the 4th. Now, is 17, is that a multiple of 4? No, but 16 is, right? We can't go higher than that, so we're going to put the 16 in there. Now, what happens to the one that's left over? We're going to put that in our non-perfect 4th radicand, all right? So that is going to be a v here. All right, now, that's a 16, by the way. All right, so 4 divided by 4 gives us just w. 16 divided by 4, right? 16 divided by 4, right? Again, this is a review, right? Gives us v to the 4th, okay? And we're left over with cube root, 4th root of v, and that is our final answer. All right, last but not least, $625, is that a perfect 4th? Yes, it is. 5 times 5 times 5. 5 times 5 times 5 times 5 is 625. All right, so we're going to go ahead and put that in our perfect 4th column. 625. All right, c to the 23rd, is that? No, it's not, right? So what can we do to get that to be a perfect 4th, right? Is 22? No. 21? Does that go into 4? No, 4 doesn't go into 21. 20? Yes, right? So what we need to do is we need to subtract 3 from that c, right? You see the c is at 23 right now. In order to make it divisible by 4, we need to subtract 3 from it. So what we're going to do is put the perfect 4th into this radicand, as this radicand, and in our non-perfect 4ths, we're going to put that next door here. So c to the 20th, all right, where did the 3 of them go? They're going to go over here into this one, c to the 3rd, right? And now that accounts for the 23 that you see there, all right? And then d to the 11th, okay, again, 11, 4 does not go into 11, all right? So we got to subtract until we find a number that does, all right? 10, no. 9, no. 8, yes. So d to the 8th, that becomes a perfect 4th. How many do we have to subtract? We have to subtract 3 again. Now we can simplify this one right here, all right, this radicand right here, and leave the other one behind it, right, as the trailer. All right, so here we go, 625. I said that 5 goes into it, all right, so we have 5 here. C to the 20th, all right, 20 divided by 4 is 5, so we get C to the 5th. 8 divided by 4 is 2, D to the 2nd, and then we have 4th root of C to the 3rd, D to the 3rd left inside, and that is our final answer. All right, fellas, that is it. That's going to be your homework tonight, is just to copy this down and post that. I already had you guys do some radical work a few nights ago. All right, we're getting back in the swing of things here. After a test, I will have those all finished up for you guys very soon. All right, I will have grades updated for you shortly as well, now that seniors are done after this week. So I've been trying to make sure that I have those guys ready to go and ready to get them out. So that's it. All right, good luck with this. If you guys need any help with anything whatsoever, it's going to be much easier over a Zoom meeting. So please, I encourage you to join those meetings if you are having trouble. Take it easy, guys. Miss y'all.